Hello and welcome to another JavaScript interview questions where we go over technical questions you might be asked in an interview. This question comes from HackerRank. It's named Birthday Chocolate, and here are the instructions. Given an array of numbers S, that would be this array for this example, this test case, numbers S. Count how many segments of length M. So M, here is the length there, that would be 2, so a segment would be this, 1 to 2, or 2 to 1. That's a segment of length 2. Sum to the value of D, so the value D is 3. Let's go through this example without code real quickly. I will initiate this variable, count equals 0, and we'll have now a segment of 1 and 2. So we need to add those together. If that equals D, which is 3, we can iterate count upwards. Then we have a segment of 2 and 1, and that also equals 3, which is D, and we'll iterate count upwards again. Then 1 plus 3 is our next segment, which means we have 4. We do not iterate the count upwards because that does not equal 3. And 3 plus 2 equals 5, and we do not iterate the count again. And eventually we will just return the count back as our answer. And we have another example here that we'll use as well, but let's get started. Okay. I am going to comment this out, and I'm going to try to get this all on one page here. So I'll get rid of test cases, like that. There we go. Now we can see S, D, and M while we go through this function a bit. So this is our birthday function. It takes in the S, D, and M like we have right here. And here's our pseudo code. This is the pseudo code for a for loop. If you want to try this before we go through it together, go ahead. We're going to do this with pure recursion as well. All right, let's get started on it. We're going to create variables to track the count and segments. This was that variable I made there in the example count. I would like one here as well. So I'm just going to let count, and we'll initialize that at 0. And we're going to use slice, so I'm going to call each segment a sliced piece of that segment. So I initialized sliced here just to no value at all. And we also need to define our edge cases. So an edge case that came to mind for me was if the length of this array is less than the segment value. So if we needed, say, 2 elements in the array to add together, but the array was only 1 element, so if I just deleted all of these, we need to return 0, because there's no way for a segment of 2 to equal 3, because there are no segments of 2. So that's an edge case I want to define right here, and we can handle it later, of course, in this loop, and we will, but let's do that right here. So we'll say if s.length is less than m, return count. And we initialize count at 0, so we will say 0. Let's move to our next piece of code here where we can finally do our loop. We're going to loop through the array, creating new arrays of m length, and that's why we initialized slice here. Let's do our loop first. That's the easy part. It's a simple for loop. So for let I equal 0, then while I is less than s.length, that's the length of the array, then I plus plus, we will iterate I upward. Now inside of there, the first thing we wanted to do is create new arrays of m length. So that's that right there, and we could see it right here in this example, m length is 2. So let's see how this would work if we want an array of 2. What I'd like to do is take my variable I made up here, my let, I'm going to pull sliced, set it equal to s.slice. Now, this can be called on any array. This is an array method. If you want to dig deeper into this, I have a much deeper dive on my channel, and I will link it here. Now, what we want to do is just return a slice of each array, and it has to be the size of m. So in this example, it'd be the size of 2. So we could start at I. That starts at 0 and is inclusive. So the word inclusive, that means that this number at position 0, that's the number 1 here, at position 0 is included in the result here. The second part is exclusive. So I'm going to write I plus m. So the number in m is 2. So if we're at 0, that puts us at this position, and we're going all the way to 2, that means this is 1 and this is 2 here. That would bring us all the way to here. That would be too many. But the second argument is exclusive. So it doesn't take what you put in there, it just takes the numbers before it. So saying 0 to 2 would just include these two, but not what's at position 2 itself. That wouldn't be included. So we made our slices right there, and we're holding them in sliced. Next, we're going to do this piece of code here. Find if the numbers in the slice adds up to d, and if they do, add 1 to count. So we can do this with another array method. This is going to be inside an if statement, so we had find if. So if sliced dot reduce. Now this is another array method. Here's how it works. I'm going to open this up and I'm going to put an accumulator in there and the current value in there. Then I will fat arrow that and say accumulator plus current. And now what happens is our accumulator will initialize at 0. And then our current value here will be added to the accumulator. So in this case, we'd have the accumulator starts at 0. The current value is this first one. That would be 1. Now the accumulator equals 1. Now the current value moves to the next piece of the array. The current value now equals 2, and the accumulator already equals 1. Added together, now the accumulator equals 3. And at the end of this, it returns whatever the accumulator is. So when it reaches the end of this sliced array, which only has 2 elements, and it equals 3, we can see that it would return 3. Now what we want to say is if all of this logic, triple equals 3 in this case, or d in all cases, so that would be the variable d, we want to count plus plus, which iterates count upward from 0 to 1 to 2 to 3, however many might be in here, and we know the answer is actually just 2. And finally, we just need to return count, and you know what, I'll just uncomment that. That's all we need to do, return count. So we got started with that, and we should get the answer 2 right here. Let me show you that. Perfect, we got the number 2, we got the proper answer. But there's still a problem with the answer we have here, and I'm going to show it to you right now. I have another test case right here, and the answer to this one is 1. Let's see what answer we get back here. And when I run it, we actually get 2 again. That's not what we want. But what's happening with this? How does that possibly happen? And this is a test case that I designed for this reason, to show you that you really need to look for edge cases. Now, here's what happens. As we slice through, we will slice the first 2 from the array, and then the second 2, the third 2, but eventually there isn't 2 left. There's just this one number. So when we try to slice 2, we only get a slice of 1 number. We just get 3 back. So that also equals 3. That array that we sliced, that gets stored in sliced, will equal 3 when reduced, because the only number in it is 3. So we want to test for that edge case as well. Let's do that right here. Now, instead of just sliced here, we want to put an if statement in front of it. If I plus m, and let's put that, I like to define this logic as boxed in as possible. This isn't necessary, but if I plus m is greater than s dot length, and what we want to say is break. Now, after that, we could do all of our logic. Now that should fix our statement right here. We're looking for the number 1. Let's see if we get it. There we go. We fixed our birthday function. And we could also get rid of this here. We won't need it anymore because of this right here. This is doing the same check, but inside the for loop. But it's always good to define these edge cases. Remember that. I hope we learned that from this lesson. And we're going into the fun part. Let's do this with recursion. All right, I will just comment this all out and let's start our recursion. Now, this is a very similar answer and it actually looks a little cleaner. Check this out. So we're going to let, we could call it answer counter, and let's just call it answer this time. Let's let answer equal 0. Now, we have to do our check on the length of the array. We have to do that first for that edge case. So if s.length is less than m, return answer. So that's for our edge case, of course, and it is the condition that this will stop its inward recursion. Otherwise, this would go to infinity. So at some point in our recursive function, we want to create a situation where s.length is less than m. So we will work on that in just a moment. We're going to use slice one more time. I'm going to make a const called mini array, and that's the same as the sliced array. And it's going to equal s.slice. Now here's something else cool you could do with slice. If I want to take something from the end of the array, I just put in a minus sign and then the amount of elements that I want. The amount of elements that I want is m. I want 2 elements in this example from the back of the array. Now why am I doing it from the back of the array? When you take something from the front of an array, the entire array needs to be re-indexed. Meaning this at position 0, say we took that out. Now this needs to be moved from position 1 to position 0. You have to go from position 2 to position 1. You have to go from position, so everything needs to be re-indexed, which is way more costly than just popping off the last element. Everybody keeps their index. So since we are going to make changes to the array to get to the s.length, I'm going to pop off the back rather than shift off the top. So that might seem a little confusing, but we are right here, we're taking a slice of, in this example, the last 2, because that's what m means, it means 2. We'll take these guys, and then when we're done with it, we'll just get rid of 2. So that means the next time we'll take the last 2 on it, which will just be these guys, and so on. Let me move that back. That's how we're finding a slice that we want to work with, and then we'll use that reduce again. So if mini array dot reduce, and we saw this last time, I'll do it one more time, accumulator current, and let's get that fat arrow, accumulator plus current. If that is triple equal to d, answer equals 1. Now I didn't do answer plus plus for a reason, and we'll talk about that in one moment. The next thing we need to do is pop that off. So that's real simple. s.pop will take the last element off of this array. So that's no longer in there. And then we want to go back into birthday. So we will return birthday. So we're returning the function birthday inside of birthday. That's what makes this a recursive call. And we'll pass in s, d, and m plus answer. So each time it goes through, we are going to pop off the last piece, and then we're going to pass s in again with the last piece gone, with that gone. And the answer will come through as either 0 or 1. So every time we go through and we hit this part, we'll have 1 added or 0 added, one or the other, but no iterating upward here. It needs to be in the return, otherwise it would get lost. Because when we reuse this function, when we call it again, we are going to let a new answer variable, and it gets initialized to 0. So if we want to keep iterating that upward, it would be impossible as it keeps getting called. So we're keeping track of the answer in the return here. Now this happens to be the entire function. So we could run this on our first example here. That should equal 2. I'll comment this one out for now. So let's get 2 back. There we go. It does work for that one. And let's make sure it works in this one with that edge case. It should be 1. And it is. We solved this with a loop. Then we solved this with pure recursion, and our answers both work. So if you're having trouble with recursion, I understand. It's not a simple topic. I thought learning recursion was like looking at something very far away come a little bit more into my view as I kept practicing it, because it just seemed like I couldn't understand it at all, and then it kept on getting into my view, and oh, I understand a little more. It's like I was getting closer to it. So if you just feel like you know just a little more about recursion now, that's a big victory, and you want to come back and learn more and more about it. I'm going to do these videos each week, so come on back and we'll do more and more. Well, thanks so much for being with me on this one. I hope to see you on the next one. Please like and subscribe, and keep coding.